Welcome to Module 13, the last module of this class, and I am coming to you again from a balcony in Okinawa because I'm doing this about 10 minutes after I just did the last module lecture. So in this one I'm going to talk a little bit about the human impacts on the environment, and I'm going to focus really on four main points. First one being, what do we mean when we talk about the biosphere, and in terms of, we have to understand what we mean by that. In terms of when we talk about human impacts on the biosphere. Then the second point is we'll talk about human impacts on plants and animals. Then I'll look at the specific case of ozone depletion, partially because it's an important case of how humans have affected the natural environment, but also because it's a very interesting example of how humans then came up with political processes to try and halt that impact. And then last we'll talk about hazardous waste and nuclear waste issues. Okay, so to start off with, when we talk about ecology, right, this is the study of how organisms interact with one another and with their physical environment. And so in this section where we're looking at how humans impact it, we're looking a lot at how human activities can change the way in which these physical systems operate. And so, particularly we talk about how human impacts the biosphere, which of course, one of the things about this is that there are different kind of ways of thinking about this, but basically humans are also part of that biosphere, right, as animals ourselves. But the biosphere is a thin film of air, water, and earth within which we live. And so we have to think about this really vast size of the planet Earth, right, all of the rock all the way to the core, the atmosphere all the way up to several miles up. And really all life, bird life, fish life, etc., is in a fairly small kind of thin film that is where the oceans, the rock, and sometimes the air meet. So we talk about sometimes three interrelated parts: the troposphere, which is the lower part of the atmosphere; the hydrosphere, which is essentially all of the water bodies in Earth, the oceans, the lakes, the rivers, the water cycle; and the lithosphere, which is the rock portion of the Earth. And really, to all this, there are two entwined components. You have the sun and its energy, which then is what usually drives most of these biological processes in terms of how energy flows through the systems, but also certain types of matter and chemicals like carbon, oxygen, that also move through these systems of living world of plants and animals. So those are some of the basic concepts, and I just wanted to hit those because that's kind of where the book sort of starts in on this stuff for this chapter. But my next key point is about the impacts of human activities on plants and animals. Rates of extinction have increased exponentially as a result of human activities. We are in the midst of what many people estimate to be another mass extinction, and this mass extinction is caused quite most directly from human activity. There are many species that are endangered or vulnerable, or threatened. There are particular parts of the world that have more levels of biodiversity than others. It says here that areas with exceptionally high numbers of endemic species are particularly at high risk of disruption from human activities right now. So there are four major ways that human activities modify animal and plant life to threaten and reduce biodiversity. I'm going to focus on some of them. The biggest one is habitat loss. This is the main cause of extinction globally. So when humans go in and they build cities, when they do agricultural activities like take out vegetation and plant fields or do ranching, when they do mining like extractive activities and development, draining wetlands, clearing forests and grasslands, this devastates habitats that some of these species rely on. And this occurs in both developed countries and in developing countries, and this again is in red here because it is the main cause of extinction today. So if you look at the environment that I am in today, we can see in the background, right there, we've got some forested habitat. But in the foreground, we see where human activities have built houses, built roads, built major highways, built really big hotels. And you can see that if this human activity wasn't here, this habitat would be very different. If all these human activities hadn't gone on here, there's a lot of other species that would be essentially living in this area. But because of this development, this land is essentially not available for those other species, and this happens all over the place. Another big impact is from hunting or commercial exploitation, right? They're overhunting for food, such as we saw in the video with one of the other modules on overfishing in the Pacific, would be a great example. But also for fur, hides, you think of some of the animals in the American West that used to be much larger populations, like buffalo, which have been hunted almost to extinction, wolves that have been hunted almost to extinction, then also things like mountain gorillas, elephants, hippopotamuses or hippopotami, not sure. But anyway, those kind of animals that have been hunted almost to extinction. Another thing that people don't sometimes appreciate just how devastating can be, another impact on plants and animals, is when humans introduce exotic species into different places. There are some islands where the introduction of a certain species, like there's a snake called the brown tree snake, which is indigenous to areas around Indonesia, was brought to an island, Guam, in the Pacific, where it hadn't been before, came through and wiped out about 13 species of birds that used to, because the snakes come and eat all the eggs, and now those birds weren't able to reproduce and are now extinct. So invasive species can cause a lot of problems, both from predation like that, but also just taking over territory. And they're not necessarily always just animals. There are also plants that are invasive species that come into an area, take it over, and then other plants aren't able to grow, and then those plant species can no longer exist. And so usually human actions are the primary means of introduction, and exotic plants may have an advantage over the native species, and the exotics lack natural enemies, like predators and such. There's one island I went to where there's these two islands right close to each other, and one of them had cats on it, and one of them didn't. The island with cats pretty much had cats, and it had some rats and that kind of stuff, but hardly any birds. Go to the other island where there were no cats, and there were nothing but seabird nests everywhere, and birds all over the place. And it's because there weren't any cats on the whole island. And so you can see how the introduction of cats to this one island totally changed the entire ecosystem and devastated the bird populations. So in the U.S., exotic species are second to habitat loss as the cost of species endangerment. Island ecosystems are particularly vulnerable. Another huge thing that people don't usually appreciate too much is that the impacts on plants and animals from poisoning and contamination. A big example of this was poisons like DDT, which were used extensively in agricultural areas in the 50s and 1960s, which do something called bioaccumulate and biomagnification. Bioaccumulation has to do with the fact that these poisons will concentrate in the fatty tissues of animals, and so those poisons kind of keep increasing as an animal's exposed to it year after year. And then biomagnification has to do with the fact that because a lot of these poisons like DDT would get into the fatty tissues of an animal, when another animal eats that animal, they get all of those poisons, and then they eat another animal, they get all of that animal's poisons, and they concentrate them. So as you go up the food chain, you get more and more of this poison concentrated in the individual animals. So things like DDT were responsible for big crashes in the population of eagles, the prey that they were eating had been exposed to DDT, and so they were concentrating it, and the DDT basically caused the eagles to make eggshells that were too weak to support staying viable for their hatchlings to hatch. And so this was really bringing down eagle populations, and consequently DDT was then banned because of its problems and the way it bioaccumulated up the food chain. All right, key point number 3. This is the impacts of depletion of the ozone layer. And this is kind of an interesting process because both in terms of the way in which it explains how human activities affected the natural environment, but also what humans then ended up doing about it. So the ozone layer is in the stratosphere, so the second layer of the atmosphere, and it protects the Earth by absorbing ultraviolet radiation from hitting the ground. But one of the things that was starting to destroy the ozone layer was the release of certain chemicals, particularly chlorofluorocarbons. Now, one thing to realize about this, because I've had students get confused in the past, this is a very different issue than global warming, which has to do with CO2. So this issue is separate from that. But one of the things that started happening is these things like chlorofluorocarbons, which are artificial chemicals, would go up into the stratosphere and destroy ozone molecules. And so it caused low ozone concentrations over the Antarctic, but also in other parts of the world. And so you have this shield essentially in the atmosphere getting thinned out. It's not blocking ultraviolet radiation quite as much. So what we get from that is more skin cancer in humans. It also can suppress immune systems, reduces agricultural productivity, and also damages phytoplankton in the ocean. So what happened is that people started recognizing that there were all of these issues and problems with these chlorofluorocarbons. And so the different countries of the world got together and made an agreement, which, sorry, it gets covered my face here a little bit, but they phased out these ozone-depleting substances like CFC in what was called the Montreal Protocol. I know it's covered here, but Montreal Protocol in 1987. And this was really important because it was one of the few times that you actually got all the countries in the world to come together and realize that they were damaging a common resource, which was the atmosphere, and that they had to make some sort of agreement so that there wouldn't be more environmental damage and kind of for the betterment of all people and the environment. And this was successful. They were able to globally phase out the use of chlorofluorocarbons, and now we don't hear about ozone depletion quite as much as a huge global atmospheric problem. A lot of people will bring up the Montreal Protocol as an example of what potentially could work with carbon dioxide emissions, that if countries of the world were able to get together and make an agreement on banning CFCs for the betterment of the global atmosphere, perhaps then they could also do that on other things. And there actually have been agreements, like acid rain is another environmental issue, where countries have been able to get together and make agreements to try and reduce the amount of acids that are being produced in the atmosphere, which then gets rained out and affects rivers and streams. And so there have been some successful examples of international cooperation and agreements, and some people think that things like the Montreal Protocol can be a model for what could happen with global warming gases, but up to this point it has not really been successful. All right, so last key point here. Last key point of the entire semester, or the entire session here, which is about hazardous waste. It's another human activity that causes environmental damage. So there's two terms here that sometimes get confused. Toxic waste is things that are specifically poisonous to humans or to other organisms. So poisonous, right? But hazardous is a little bit more all-encompassing. They can be things that are explosive, that could catch fire, the other kinds of hazards besides just being toxic. So sometimes these terms get used synonymously, but there are some specific definitions here. Now, one type of waste that is particularly kind of insidious or problematic is nuclear waste. And to understand how nuclear hazardous waste occurs, we have to understand that there are basically three kinds of radiation that get emitted from nuclear materials: alpha, beta, and gamma. Alpha particles consist of 2 neutrons and 2 protons. So when a nucleus, and we remember from last module, we talked a little bit about what happens with fission, right, in terms of how when atoms are split for nuclear power or for nuclear weapons. What happens often is that it will eject these alpha particles, which are 2 protons, 2 neutrons, which are relatively large, nuclear speaking, but they don't penetrate very much. They actually get stopped by an outer layer of skin, or a piece of paper will stop an alpha particle. They are still, however, very problematic in that they're fairly powerful because of their size. So if you ingest them, if you eat them, or if you breathe them in and they're on dust particles that you breathe in, they may get stopped by whatever they hit, but if what they hit is the inside covering of your lung, or inside your stomach, or inside these sort of things, these alpha emitters can actually be quite damaging. The next kind of radiation is beta radiation, which essentially is an electron being ejected by the nucleus. It can be stopped by a layer of clothing or by aluminum. They penetrate a little bit more. They penetrate into your skin. If you get close to a beta emitter, it will give you a burn, like a radiation burn. The last form is gamma radiation, and this is a form of electromagnetic radiation, not really a particle. It can pass right through your body, through several centimeters of lead, or through a meter of concrete. In the example earlier in the semester where we looked at things with like the Fukushima nuclear disaster, gamma radiation is the biggest problem, and that the particles that produce gamma are scattered everywhere, and if they're in the soil and you're down, those particles are emitting gamma radiation, and it's going straight through your body, hitting parts of your body and then causing damage. So the damage caused by alpha particles is actually 20 times greater, but it just doesn't penetrate as much. So you have to worry about inhaling alpha particles, but gamma is just all over the place in the environment, passing straight through you and hitting you in all sorts of places internally. So there's different dangers associated with all these kinds of radiation. And where they come from can be from nuclear accidents like Chernobyl, which you'll see a video about, or like Fukushima, which we talked about earlier in the semester, but also where the uranium is being mined. This shows the nuclear fuel cycle, right? Where the uranium is being enriched, where you're getting the fissionable uranium. What you do with all the spent fuel from nuclear reactors is still very radioactive. And so all this stuff is sitting in different places, causing different kinds of hazards and problems. And in the US, we have a problem with nuclear material from all of this. But places like Russia, which also have had a long history of nuclear production, have even worse problems because they haven't had quite as much oversight on where they dump their material. So in the US history, there's lots of examples of us just burying it or dumping it in streams or in oceans or just letting it sit around. But in Russia, that stuff's been even worse. And so there are problems with nuclear contamination in Russia are actually very widespread, although there are also a lot of places in the US that have it too. Just going to skip over that for a second. So this just kind of gets into some of the, just how much radiation problems there are in the United States. So there are over 3,000 contaminated sites containing hundreds of underground storage tanks, millions of 55-gallon drums of nuclear waste, thousands of sites of contaminated soil, places like Hanford Reach in Washington State, Savannah River in South Carolina. These places are phenomenally contaminated. And, like I said, there's lots of different ways in which this can affect people. It can get down into the groundwater. There's leaching, where the radioactive material might leak down and hit into the water, or be just soil contaminating. You can get affected by gamma radiation just from walking through the area. The wind blows the particles and then lands in places downwind. And so there's all sorts of problems with the way in which you can get radiation can spread through the environment. So currently, the U.S. continues to produce over 100,000 cubic meters of low-level radioactive waste every year. And it gets buried in disposal sites in places like Carolina, Washington, and Utah. And back in 1986, there was a deadline for each state providing its own storage sites, but and there was all these different plans for there to be a national storage site, but a lot of them have not really worked out. So right now, most of this nuclear waste is being stored on site. So like if you live near Keene, the Vermont Yankee power plant over near the Vermont-New Hampshire border, the nuclear waste it produces is just being stored on site. That's just where it is. There is no currently permanent disposal site for either low-level or high-level nuclear waste. And then, of course, there's the nuclear problems that happen from things like the Fukushima disaster or Chernobyl. And Chernobyl was located here in the Ukraine near Kiev. And what happened with Chernobyl is that it was an accident that happened while they were doing a test on the system. And you'll see a video that gets into some of this. But basically, within 5 seconds, the energy level of the reactor increased 2,000 times, and the core caught fire and blew up the whole reactor. There were immediately about 37 deaths, 500 people hospitalized, many with acute radiation sickness, but over hundreds of thousands of people ended up being contaminated, and many of which developed more long-term health problems. Particularly, there's something called iodine-131, which is really a problem in the first month or so after a disaster. It has a fairly short half-life of a matter of days, but if you're exposed to it, it can give you thyroid cancer. It's one of the reasons why, even in places around nuclear plants in the U.S., like in Brattleboro or other areas near Vermont Yankee when it was operating, we'll have iodine pills on hand in like schools and other places, because if you flood your body with regular iodine before you get exposed to the radioactive iodine, then your body doesn't take in as much of the radioactive iodine. And so it's one of the things that people look out for near these disasters. And around Chernobyl, there's been a huge increase in thyroid cancer. And so this is just looking at the building that it destroyed as the thing came up. One thing you'll see in the video is actually a short segment of the video where Mikhail Gorbachev, the former head of the Soviet Union, was talking about just how much bigger the disaster almost was because some of the radioactive waste, or excuse me, radioactive core of the nuclear plant almost came through the bottom floor and then would have gone into the groundwater, reacted with the water, and created a giant nuclear explosion that would have devastated a huge chunk of the Ukraine and spread nuclear radiation over a much, even larger portion of Europe. So it was almost a much bigger disaster than it was, but you'll see some of that in the video. Another big thing that has caused a lot of nuclear radiation is nuclear weapons testing. Most people are not aware that there's been over 2,000 nuclear bombs exploded on the Earth in the last 70, 80 years. So you can see the places, and there's a geography to this, right? So places in the Pacific, like Bikini Atoll and Inuitak, China has exploded nuclear weapons. India has exploded 5, Pakistan 5. The Russians have exploded them in Russia and in Kazakhstan. But you can see the place that actually the most nuclear weapons have been exploded is Nevada, with 935 nuclear weapons have been exploded there. They've been exploded in Alaska. Believe it or not, Mississippi, Colorado, other places like that have also had them too. Ukraine, a couple, etc. So Australia, 12. So you have had these nuclear explosions all over the place that leave quite a bit of contamination that lasts for many, many years. Okay, so these are some of the videos that get into that. Chernobyl video, parts 1 and 2, and also there's one that really connects with some of the stuff more from last module, but it really has to do with human impact, so I kind of put the video here. It's real short, 3 minutes, talking about the problems with oil pollution in the Niger River Delta in Nigeria. All right, so that is the end of the key points and the end of this particular PowerPoint. So make sure that you are looking at that chapter for additional information where they talk about things with air pollution and solid waste management, that kind of stuff. But for this module and for this semester, or this term, we're done. So thanks for participating in the class. I hope that you enjoyed it, and we'll have the final exam coming up soon. And good luck. Thanks.